This is the fourth tutorial of CATiA DMU Kinematics. In this case, we're gonna make two cubes following a surface. So it's almost look like a roller coaster case. But the key point is as the first cube goes, and we're gonna have a one connection edges and keep able to follow, and also at the same time both cube will be able to follow the tracks. So we're gonna simulate that, and it will be very good reference for point curve simulations as well. So I'm gonna start with the new assembly. I'm gonna put the rail first. And cube 1, cube 2. Okay. Right, so let me fix the rail first, which will be stationary part. And I'm gonna manipulate it. Alright, assembly. So we're gonna put cube 1 lead the move, and the cube 2 will follow. So basically, we're gonna line it up perfectly at the bottom and make this cube 1 start going up. So cube 2 first. So coincident, of course, the surface and surface. In this case, they're gonna look at each other. Good. And I'm gonna make also coincident. Make the edges line up with edge. Okay. So if I update it, it's right there. Because of that, still it should allow the prismatic move back and forth. But again, the limitation of the assembly design, the CATiA, is as soon as it past the straight line, again, as you can see, it will penetrate on the part. It's not really a physical phenomenon will be accurately simulated. So that's why we are relying on the kinematic simulations. So Q2 is there. Then we're gonna put the cube 1 top of it, and eventually we're gonna have the bottom of cube lined up with the bottom of this rail, or edge of cube and line up with edge 1. So that is going to be our starting point, and eventually move up. So same thing, coincident. So so surface and surface. And edge to edge. So if we update, it's right there. Now our intention is making this one lead. So as number 1 goes, number 2 follow. That's the idea. So I'm gonna move up. Now, you may have to think about it when you reach to the curve, the number 1 will start rotated, and number 2 still need to follow. So you have to make a decision or think well how they has to be connected to each other. And by giving you the answer, matter of fact, this edge and this edge of those cubes, they have to be coincident. So it pulls up, then it will follow. But as soon as number 1 is start changing angle, but still number 2 will be able to follow, but it will be definitely different speed as you see in the different point in the case. So to do that, I need the coincidence between these two edges and update. They're connected. So if I manipulate it now with number 1, at least it should follow. But again, still, if I go more than those, it will just penetrate it. So now I need to send it to the initial simulation point. So I'm going to line it up at the bottom. Probably the good way will be coincident between bottom and bottom surface. So again, this will be temporary constraint. So after you line it up, after update, you can delete it, or you can just leave it. Then we can just, when we move to the kinematics, we don't need to worry about this fixed position, because we're gonna make those joints manually. So now let's move on to the kinematics. Okay, let's get into the kinematics. Start digital markup, kinematics. Then if we look at the part in the assembly, we're gonna make this cube go up. We could have making the planar joint, which is making the one plane and the other plane continually meeting each other, but it's not gonna work as soon as it touch to this curvature area. So those gonna be violated. So in this case, what we're gonna do is point to curve a line and point curve so that this cube is stay with the path over this line, and those front will be done. Then back, same thing, point to curve, but because of this 2-point curve already made, there's no other movement now, so we're gonna use that only one side, so point curve. Then we're gonna have the same thing, the top point curve and point curve. Then as this first cube will move up and change the angles, we need to still making this one follow. So what we're gonna do add is right here, the line and line, they are actually either revolute joint or cylindrical joint. Since we have a point and curve, it's may not necessary. So with that plan, we can start. Point curve is right here. Point curve. So, oh, sorry, let me fix first. Fix new mechanism. I'm gonna fix this rail. There we go. Then point curve. Let's start with this end one. So curve will be this one. As you can see, automatically it's gonna pick only one, but eventually as soon as you pick one point of other part, whole the tangent line will be recognized. So it's waiting for pick a point. There's a point. There you go. Now you can see it. The whole curve is linked to each other, which was only partially selected. Now everything is selected now. So that's one. I'll keep doing it. Same thing. Point curve, curve, and point. Okay. So that was the second joint, point curve. Then we're doing the bottom of this cube. So I'm gonna hide this second cube for just for a moment. Point curve, curve, and just point. There we go. Then I'm gonna hide this guy and go to hidden place and hide the second one. So I'm gonna do the same thing. So point, curve, I don't need to do this one because we're gonna connect one edges to the other edges from the other cube. So another point curve, point, again, point and curve and point. Right there. There we go. So now, as you can see, we have a 3 degree of freedom. The reason is, again, those two cubes are not linked to each other yet. So what I'm going to do is this edges, bottom edges of first cube, and the top, the edges of a second cube, we're going to make it as either revolute joint and cylindrical joint. In this case, it's not necessary the revolute joint. So I'm going to make cylindrical joint, and I'm going to go pick up this edge and this edge. That means they're gonna connect it always each other. So it's sharing the same axis. And watch the changes of degree of freedom for this mechanism. As soon as I say OK, then right away you can see it, only 1 degree of freedom left because only motion, the linear motion is left. So we're gonna take over one point curve, which was the first one. We're gonna use this one as our command driving mechanism. So let me put it back. So I'm gonna make first one, and we're gonna take over as our command. So it's length driven. So you automatically calculated whole the length of our rail as amount of a travel to make. So as soon as you say OK, then right away you will see a command is available. So if you kind of simulate it quickly with the command, and you can very easily see how it's going to travel. Here we go. It's going there. There we go. It's perfect. Bring it back. All right. So then now we need to put a law how quickly it's going to move. So we can have formula for the mechanism. So the length we will travel with, as an example, 100 millimeter per seconds of speed. Then we can add our kinematics time so that the units are homogeneous. And say OK. Then we can add the sensors to where we are interested in. So maybe we can see how second cube quickly move in X direction, Y direction, or something like that. So we're gonna add a sensor and one of the position we are interested in. So reference will be our base, and point where we're adding will be here. There we go. So now we simulate and activate the sensors. I don't know how long it's gonna take, so let me just activate the sensor, and we're gonna automatically stop after you make a travel. And in this case, let's say how fast in Z direction, in height direction wise, quickly move and eventually going down. So let's say Z vertex, Z linear speed, and Z linear accelerations. Check the instantaneous values. That's the current one. And once you start to simulate it, oh, it stopped. Again, it's not correctly moving everything. I'm not sure exactly where is the problem is, but again, I think you got the idea. So with the same idea, what we're gonna do is we're gonna making the garage door for the second assignment this week. Um, so that you're gonna utilize a point curve most of the case, and again, wherever those two panels or two objects need to be aligned and rotate, it's gonna be done by the cylindrical joint or revolve joint. Okay, we'll discuss more detail in classroom. Thank you.